So before going ahead with today's session, you guys have any doubts related to previous sessions?
No, Venkat.
No, Venkat.
Okay, you Bhagiraj? Hello.
No, Venkat.
Okay, yeah.
No, Venkat, nothing.
Okay, okay. Today we will start with the deportation components. And we have four deportation components: concatenation, gather, match, and interleave. So what we learn from the partition components? So whenever we are getting a huge serial file, to make the process into parallel, we were using a partition components, and the parallelism can work on depends of the MFS file system. So if my requirement is again to create a load ready file or the landed file into a serial for the processing of the next loading into a staging tables, or it could be a target tables, or it could be a processing with the other graphs, but my requirement is to create a serial file, then we have to use a deportation component. Then only the flows which are running on the parallel will come into a serial by using any of these components: concatenation, gather, match, and interleave. But everything will do the same. A serial kind of file will get created, but the behavior is so different for each of the component. It depends on the requirement. We have to use which component to be used. And the first component is concatenation. By the name itself, we can understand that it is going to concatenate. But how it is going to concatenate is, it reads the data in the partition 0 file. Once completion of all the data it has read at the partition 0, then only it start reading the data from the partition 1. Even the records are ready to come over the flow to the serialized. Still, the concatenation component will not read the records on the other components. Still, it processes the previous component. So if it is a four-way, then because over the flow, the data has to be ready, the records has to be ready to come over the flow. Sometimes what it happens is arbitrarily the records which are on the other partitions will be ready than the previous, like 0 or 1. The records which are in the second and the third partitions will be more ready than the records in the partition 0 and 1. But what if we are using a concatenation component? Even though the records are arbitrarily ready to get it into a serial format or a serial flow, but the concatenation component will not read those kind of the records. It will wait for until it processes the partition 0 records. Then it starts picking up the records from the partition 1, then partition 2, then partition 3. So that is how the concatenation component will work. And coming to the gather, we don't have any requirement, just I need to make it into a serial flow. However, it could be the order. I'm not going to bother. Then in such a case, we have to use a gather. This is the fastest deportation component which will make the flow serial. So most of the times we use gather component. And coming to the concatenation and gather, we don't have any parameters. The behavior will get changed, but most of the times we have to use gather because it gives performance. It reads that data arbitrarily over the partitions. So in such a case, whichever the record is ready to be coming over the flow to make it serial, all those records will be reading it. And we have a component called merge. So this is something interesting, the component when we have to use the merge. It has a parameter called key. So the data coming over the flow, that is partitioned records, or coming over the flow on sorting to one of the key. Let's say I'm doing a partition on the department number, and in some of the flow I have made the data over the partitions to be sorted by using a sort component. So now the data coming on the partitions or sorted order, and I want to make it the order as it is. So even after I creating the load ready file or the output file in the serial format, the data should be in the sorted order. I don't want to use another sort component. So if I'm using a gather component, what will happen? The flow will be serialized, but I cannot guarantee the data will be in the sorted order on the department number field or whatever the field what is already which is sorted on the flow. If you are using a gather, the flow will become serial, and along and at the same time we are expecting the data in the uh, serial file to be sorted on one of the field, then we have to use a sort component. So instead of using two components, gathering into making a serial and then sorting it on the flow, so that is not a suggestible way. If you are expecting the
Yeah.
serial file to be sorted on one of the key which is already sorted over the flow on different partitions, then the best component to use is a merge component, and define the key on which field you are expecting the data to be sorted and make it into a serial file. But let's say the data is coming on the department number or sorted order on the department number, and I am expecting the data to be sorted on the job field, then we should not use a merge component. It will not come on the sorted order. This is something, excuse me. Okay, sorry boss, I got a important call, so I have. Okay, so in such a case, we should not use a merge component. If you are using it, the data will not be in the sorted order. So whatever the data is sorted on the flows, and if you are expecting the data to be sorted on the CL file on the same key, then only you have to use a merge component. Otherwise, yeah, if requirement to be on the different field, then use a gather and then sort component. We don't have a choice in such a case. And then we have a component called interleave, and here also we have a parameter called block size. So can you tell me where you have seen a block size parameter in any of the components?
So partition by round robin.
This one, yeah.
Yeah, block size, correct. We have seen the partition by round robin. So based on the size, whatever we have defined, those many records will be distributed to each of the partitions in a round robin fashion. So if your requirement is again to make it into a serial, however the way you had distributed. So let's say input file has 10 records, 1, 2, 3 until 10. So I have given the block size as 2. So first 2 records will go to 0th partition and 3 and 4 come to first partition. Then 5 and 6 will go to 0th and 7 and 8 will come to first partition. Then 9 and 10 will go to 0th partition. So again I have to just make it into a serial flow. It's like an undo operation. Whatever the input file we have it, we have processed so far, and doing an undo means the sorting of the records whatever we have it on the input file will be exactly equivalent to the output file. If that is the case, then we have to use an interleave, and if and whatever the flow which got partitioned, and that could be with the partition by round robin only, then only we can get the order of the output file will be equivalent to the input file. And we never, most of the cases we never expect in this kind, so very less we will use interleave. Most of the cases gather and the merge components we will be using it. So let's go into practical. Okay, here we have two examples. So one with both the serial files and one with the multi-file. Let's look at the data of the serial files. Let me run the cam. We got 10 records. Okay. The first records we have in the input file one is these 5 records: Sharon, Suman, Kalpana, Mamata and Madhu. Sharon, Suman, Kalpana, Mamata and Madhu. The first 5 records has been read from the input file 1. Then it started reading from the input file 2. Vimal, Roshni, Shravan, Jay and Preeti. So let's look at the partition data. So even for the partition data also, the behavior will be same. It has to process all the partition 0 records, then only it can go for partition 1. So this is how the concatenation component will work. Gather. So here we don't have any format. It reads the records arbitrarily. Whichever the record comes first, it will be clubbing into serial flow. And this is the fastest component. So here order we cannot see it. So by looking at this output, don't get confused by saying that all the records from the in1 has been read, then all the records from in0. So it's not like, so this is not the behavior of the gather component. The reason how you are saying here is it has very less records. At each time when it connects to each of the partition and reading the data, it reads the bunch of the records. So in real time we will be having the lakhs of the records. So in such a case, some thousands of the records at a time it will read over the flow and then club it into the serial. Then over the flow of the partition 0, it reads the thousands of the records and club it here. But as here we have very less records, we can feel like all partition 1 records might be reading first and then partition 0. No, that is the behavior of the concatenation by reading partition 0 then followed by partition 1. But here it is different, the gather. It reads the data arbitrarily. Merge. So one with sorted flow I can see and the other with unsorted, and both having the multi files. Let me run the graph. Okay, and what is the key we have given here? The key we have given is department number. So in each of these departments, it is sorted, and each of the partitions 10 and 30 and 20. Oh, sorry, here it's not sorted. Okay, it's not sorted order. So let's look at the data how it comes. So obviously the output will be in unsorted order. But if the data is sorted order on the second flow, we are making the flow to be sorted. So let me put the watcher here, and once again we will run the graph. Okay, so now the data is sorted on each of the partitions 10 and 30 sorted, and within the partition 20 and 60 got sorted over the flow after using a sort component. So now it is making the flow as a serial flow, and the data is in sorted order. All 10s, all 20s, and 330s we have it, and 360s we have it. So here we are using a merge component. It's a deportation component. So can you guys tell me, like, here we have how many merge operations has been performed totally? In this graph, totally how many times the merge operation has been performed? Can you guys think?
Is it
Pardon?
No.
is it two times, one for the unsorted data and one for the sorted data?
Okay. Mm, st Still you can think how many totally we have it. I'm not asking at the graph level. How many out of these components totally how many times the merge operation has been performed? So you can look at how many components we have it and what kind of the components we have it. You Borgeras, any answers?
No. No, I'm not getting.
No, in this components how many we have it? 3 plus 4, 7 components we have it. So out of these 7 components, how many times the merge
Yeah.
operation has been performed? So now we were discussing about the merge component. So do we discuss anything prior to this about the merge?
No.
You Ravali?
I am not sure.
Mm, okay. So, okay, one clue I can give you. We discussed when we were discussing about the sort component. So, how the sort will happen?
Uh, Sort will hold all the data and it will work on that, right?
So, whatever the
It will.
amount of the memory we have specified on the max code parameter, it will read that data from the
Yeah.
input file and load it into the RAM and does the sorting and creates a temporary file on the disk, sorted file. So like this, the whole operation will be performed for all the records. Then it does a merge operation, right? So if you're getting a multiple temporary sorted files,
Okay.
so it has to sort it and merge it. So sorting is done already
Yeah.
in each
That's
of
it.
the file. Like this, we will be having multiple temporary files, sorted files. So what we discussed, once the file has been sorted, it will write into the disk the sorted file. Again, it will read the amount of the data specified in the max core and does the sort. And again, it will write the sorted file in the disk. So like this, all the operations has been performed. We have multiple sorted files on the disk. So it has to make it serial. So it has to done the merge operation, right? Internally. So now can you guys tell me how many merge operations are performing in this
Yes, yes, yeah.
graph?
3.
You Ravali?
I'm also thinking as three.
Mm, Still something you have to add up. Still, can you think how many we have done?
I don't know. I still think it has 3.
Okay. How you are saying that 3?
2 merge components and even sorting the data.
Okay. So in sorting the data, how many merge we are doing, merge operations?
That based on the files, right? Number of
What files?
sorted files.
What files?
Number of sorted files.
Okay, that internally it will take care. We no need to concentrate on that. How many sorted files will get created? It depends on the data, how many, and the size of the max
Okay.
core. Internally, that temporary sorted files will get
Yes, sir.
created, and only once merge operation will be performed. There, we don't perform multiple merge operations. Only one time it will happen. But one thing you are missing is like, so what is the flow we are getting to the sort component? It's a multi-flow MFS file system. If you can look at the sort component, the number is saying that it's 2 on
Yeah.
the sort component, right?
Yes.
So when I look at the
Yeah, yeah.
data on the watcher, am I looking at a one time, the whole data, or couple of times? So I'm selecting partitions and partition 0 and partition 1. So we have 2 sorted files. To make these sorted files internally, we will be having each of the partition having multiple temporary sorted files, and one merge operation has been performed on each of the partition. So totally 4 merge operations are performing it. 2 explicitly components we have it, merge as a deportation component, and using the sort component, as we have a MFS file system of 2-way, uh, each of the merge is performing on each of the partition. Partition 0, one sort and merge is happening, and partition 1, another sort and merge is happening it. So clear how we are performing the merge 4 times?
Okay, so on the unsorted graph, we don't
Yeah.
consider the file systems, right? Because it's only one merge operation.
Yes, we are not using the sort component there. So if we are using a sort component, then again it comes to like 2 times extra, because we were having the 2-way MFS file system. So if we are having a
Yeah.
4-way MFS file system, then the sort itself will having the merge operation 4 times.
Okay.
So it's clear?
Yeah. Okay.
Yeah.
Yeah, okay. Interleave. Okay, so what is the block size we have given? Block size default as 1 we have given. So how the round robin performs the distributing of the records from the serial to the multi-flow. So this is quite opposite. It reads the data according to the block size, whatever the value we have specified in each of the partition. So the default is 1. So we were reading the first record from the 0th partition, Sharon, and the first record from the first partition, Shravan, and Suman, then Kalpana. So it is which is equivalent to like round robin fashion. So we will be saying like undo for the round robin, but we have to make sure that whatever the flow that coming over the flow and whatever the block size it got distributed, that should be same in the interleave. Otherwise it will not be like undo operation, or the output file will be equivalent to the input file, the order of the input file. So is it clear?
Can you come again?
Pardon?
Can you tell me once again that
Okay.
block size?
Okay, so what I mean to say is the using the partition by round robin component. Let's say I have done the block size as a 2. So I'm getting these 10 records. So whenever we are using a partition by round robin partition components, the flow is serial and then we are making it into parallel. So if I'm using this as an input file and I'm doing partition by round robin by using a block size 2, then these two records will go to 0th partition and these two will come to first partition. Then these two 0 and first, then 0. And similarly, while using the interleave and making it as a serial flow, I have to maintain that block size value. If I've given here the block size as 1, then definitely the order of this output file will not be same as the input file. So what here in such a case, 6 records and 4 records will be there. So I'll be reading one record from each of the partitions. So definitely the order will not be equal, output file of the order will not be equal to the input file. So we have to maintain this consistency in both the components. Whatever the block size you have specified in round robin, the same block size has to be maintained in the interleave if you are expecting the output file to be same as order of the input file. Is it clear, all these deportation components?
Yeah.
You
Yes,
probably?
Venkat.
Yes, Venkat.
Yeah. Okay. And sorry for this today also, I need to go to office early. So I wanted to close the session for today. And from tomorrow we will be
Oh,
having a 1 hour session. Is it fine for both of you?
Okay.
yes, Venkat.
Yeah, yeah.
Uh,
Yeah, yeah.
can we, or are you still having the other class from 6 to 7 a.m. or are you done, Venkat?
Uh, Still 3 more classes actually. She is not logging in daily. So due to the office,
Okay, when she's not logging, can we have an early class if, if
maybe
you both don't have
from
any problem?
next week I can tell you. But how it is for Bhagyaras, because Bhagyaras is a. Do you have any problem for 6 to 7?
No, Venkat, nothing. I
Is
can
it fine
join.
for you, 6 to 7?
Yeah, Venkat, I can join. I can join. No problem.
Okay, fine. I will let you know to both of you from when we can start from 6 to 7.
Okay, sure. Thanks, Venkat, because 9:30 is like very late for me. I mean, 10:30 is like very late for me in the night.
Okay, okay. So you will be logging at 10:30 or 9:30?
I mean, and the class goes from 9:30 to 10:30, right?
Okay, okay, fine, fine. Okay, okay. Yeah,
Yeah.
definitely I'll try to make
Okay.
it by
Yep.
soon.
Okay.
Yeah. Thanks, Traveling and Bhagyaras.
Thanks, Venkat. Yeah. Bye.
And Venkat,
Yeah, yeah, Bhagyaras.
Venkat, one thing.
Yeah, yeah.
What is the batch processing in Abinitio?
Pardon, what is the
batch processing in Abinitio.
batch processing?
Yes.
Yeah, we will be using scheduler tools, right?
Yeah, that is for common for all, right?
Yeah,
I
yeah.
mean, to
Scheduling tools
run
that,
multiple programs at one time.
pardon?
Means if you want to run multiple programs at one time, then we will go for batch processing in normal case. But
Yeah,
is
again,
it
we
same
have
in
to
ab
check the
initio?
dependencies and all that could be done using this scheduling tools only.
Okay.
And we do have one scheduling tool from the Abinitio Corporation itself, but I don't think so. Most of the projects they don't use this because we don't have how the other scheduling tools will support. In Abinitio, we have that is operational console. We call it as op console,
Okay.
but we never use that.
Okay.
We use op console just to monitor the jobs. I mean, not monitor. Once the graph has been ran or while it is running it, we can look at the operation console where exactly the graph is running. So such kind of things we will do it, but just to monitor the jobs and all, we will be using other scheduling tools like TWS, AutoSys, Control M.
Mm-hmm. Okay.
Anything else, Bhagiresh?
No, nothing. Fine. Thanks.
You, Ravali? Anything else to be discussed?
No, Venkat. That's it.
Yeah, okay, fine. Yeah, we'll see tomorrow then. Thank you.
Thank you.